Well, this presentation and the next are just an application, we could say, within the framework that I set up earlier during my previous presentation. So what I do think is interesting is that, as I said previously, we have studied, we have analyzed. Now, what proposals do we have? What concrete proposals do we offer to contribute, to help to set a certain trend or to go in a certain direction? Well, I just wanted to talk about the context of stabilometry. In the context of stabilometry, because very often there are misunderstandings. And people think that the pressure center can be controlled as though it were the projection of the gravity center over the basis for substantiation. So that's a mistake. The gravity center is a geometrical point in space that has a certain dynamics. So when standing up, it has a certain velocity, acceleration, and angle. So we calculate this with great precision, and we know in any moment in time what's the velocity and the angle of the gravity center. Now, the pressure center, the coordinates of the pressure center are the neuromuscular answer to the position of the mass center to avoid the fall, to maintain the projection within the wide base gate. So that is why these are very different conclusions, and that is the reason why force platforms are the preferred tool to do stabilometry studies until the Eurotron got here, and I will explain that to you later on. Because force platforms are the only possibility, the only technological possibility to measure the instantaneous coordinates and position of the center of our massa center. So we can study the dynamic of the pressure center in different contexts. All of this in the literature are mathematical tools that allow you to characterize the dynamic of the pressure center that start with something more simple, which is the range of movement at X or Y, so that we can reach the algorithms of the theory of chaos of fractals that allow to analyze the variability of this dynamic. What is interesting is to observe these phenomena here with regards to the dynamic of the pressure center, of how, if, for instance, I have it here, for instance, then it leaps forward and then it goes here and it moves here as well. So I have nodes around which the system stabilizes itself, and this is actually the neuromechanical answer. This is what really interests us and what we want to assess in different frameworks.
Bien, nosotros, esto sí que es interesante para contextualizar un poquito.
Now, this is very important to set the backdrop for this work. These were the results of studies conducted on posture stability in different brain paralysis clinical presentations. We have worked with brain paralysis and Down syndrome as two extremes of hyper and hypotonia, and we wanted to determine how close we were to actually analyzing these things. Well, regarding the posture stability of those people that have different clinical presentations of spasticity, and we haven't been able to yet cannot characterize them adequately. We call them diplegia, but there's 8 types of diplegias. So here there's a very high variation coefficient, which is something that circles back to variability, the concept that I mentioned earlier, which is not having a homogeneous sample. So in order to determine care policies, we need to consider the high variability or the high variation coefficient in respect to the y-axis, the x-axis, and the different parameters. And in another study, we have determined that the performance of those individuals, their neuromuscular capacity or their neuromuscular potential, call it what you will, has an impact on the quality of posture stability. The greater the characteristics of the isokinetic machine at constant speed, the greater the posture stability. So that means that if I want to train individuals in this group so that they can maintain their posture balance, I need to use isokinetic machines. Here you once again see the high variation index presented by this group. And this describes what I mentioned. When there is a negative correlation coefficient with a relative coefficient correlation, this is what really matters. The correlation is what really matters. The cause and effect. And in general terms, the greater force, the greater the capacity they had to stabilize their upright position. These are the different protocols that we have to assess posture stability. Now, if I have time enough for this, I will go back to this, because with this study, what we've done is to develop this robot, this machine. What this machine does is the following. It's a force platform, but it doesn't just measure the horizontal dimension. So it performs stabilometry, but at the same time, we can coat the support surface with any material you want, so that the wear coefficient, because we know it's the result of the tangent forces. So this is a very good prediction method, because normally with a force platform, you just measure the horizontal plane. This is what in Spain we call innovative public procurement. And I would like to mention this very briefly, because this could be very interesting for many of you, because the innovative public procurement is the battle horse of the European Union for the next 2 years. That means that research funds are not granted so that I can expand my curriculum or I can get a scholarship. We need to perform works or research work that has some sort of industrial impact. And they say, okay, you are acquainted with the subject matter. What is the gap in the market? Is there a technology or a machine that you could introduce in the market so that you can help it advance? Well, on this basis, we have decided to develop this robot. And what you do here is, well, you configure it, of course. But by the way, our inspiration was Boss's disc. I once went to a physiotherapy office, and they had a half a sphere there, and they made people stand there so that they could train proprioception. But how do you train proprioception? You cannot control anything with this. You don't know what the stimulus is. You don't know what the response is. You just do it using your eyesight, I guess. So what we do here is to do precisely the same, but we robotize it. So you determine the slope, and therefore you're given the individual a motor problem to solve, and therefore the individual adapts to it. And by the way, tribology was brought up in many lectures, in many plenary lectures. So we can indeed use the friction coefficient that we want for this. So you can configure it, and therefore you give it a problem, a motor problem to solve, and then you obtain the answer, or you obtain a response. Also, the technical aspects are very important. And once again, we need to mention that the 4 sensors included in the system are better than any other commercially available system in this type of force machines. And I'm about to finish with this ecosystem. This is the ecosystem that we would like to create. At this time and age, we are now exhausted of seeing each of us fight our battles individually, because we miss out on many opportunities if we are isolated. For our guests, our international guests, we are located in Cáceres. Cáceres is in the middle point between 2 European capitals, Madrid and Lisbon. So our door is open in Cáceres for any collaboration proposals that you may want to. But I'm the next speaker, right? Yes, you are the next speaker again. Now nos va a hablar también de la estabilometría aplicada.